This is the maths workshop for today, and we are looking at collecting and representing data. So there's lots of the questions that you'll see are visual questions, there's graphs, and the rules are with the graphs very similar. So it's asking for a 1 marker, it's asking something very basic. It might ask you to be plotting a point. What is that point? So what are the coordinates of a certain point? So you'll find with graphs, it's the visual side of it. And I've made these a little bit bigger today, so I'm hoping that everybody can see these quite clearly. What we'll do, we'll go through these, and if there's any questions, please email me or message me, and I'm happy to help. Akil joins the athletics club. He practices throwing different weights of shot put. The scatter graph shows the length for the different weights of shot put for each of his 14 throws. What correlation does the scatter graph show? If things are on the up, it's positive. If things are on the slide, negative. If they're all over the place, the dots, there's no correlation, but generally they're going to ask you a question where there's one correlation or another. So as you can see, the dots are clearly on the slide. We could draw a line of best fit in there, and it's a negative line. So for 1 mark, we would just put negative. If you wasn't sure about the word correlation and you wanted to tell them what the relationship is, you could say here, the lighter the shot put, the further Akil throws it. So you could explain the relationship if you weren't so sure what that word correlation means. So you could say, I can see that the lighter the shot put, the further Akil throws it. And you still get the point for that. You're explaining the graph. But if you're talking about correlation, trying to give those two words, a positive correlation or a negative correlation. Let's scroll to the next question. Scatter diagram shows the length for different weights again. The standard weight of a shot put used in Olympic Games is 16 pounds. And it gives us our conversion there. Explain why using the scatter diagram is not appropriate to predict how far Akil will throw it a 16-pound weight shot put. So first of all, explain. So it's asking us to put a line of best fit in there, and that's not the best line of best fit, but we can put it like that. And then we've got a one of 16 pounds. So let's figure out what a 16 pound, this is a dumbbell then, 16 pound shot put weighs. So we can see that 1 pound, we'll put LB, is the same as 0.454 kilograms. So if we've got a number here that's 16 pounds, we can see it's 16 times bigger. So we've multiplied that number by 16. So we have to do the same on the other side. We have to multiply that number by 16 because we've matched them both up. So it's a calculator paper, as you can see. It's a C, so we're absolutely allowed to use the calculator we've brought into our exam, but you're not allowed to use the one in the computer. It has to be a physical calculator. So you can see what I'm typing in now. It's better that I use the computer calculator. So we've got 16 multiplied by 0.454. And we've got a weight in kilograms of 7.264, 7.264 kilograms. Now we can go back up to our diagram. And as you can see here, look, we've got 7.5, 7.2 somewhere here. If we were to look at that and think, if we're following our line of best fit, because it doesn't go that far, he's not used one that heavy yet, has he? So if we're going line of best fit and we'll carry on going forever, well, not forever, but just below the diagram. If you think here, look, for a 6 kilogram one, it'd be about that far. For 7, if he's 7.2, it's actually showing he's going to be negative. He's not going to throw it. So it's not appropriate to use this scatter diagram because it'll give you a negative number, and you can't throw something a negative number. You're not going to throw it behind you. So explain why. So if shot put, and it's double T in it, shot put is oh no, it's 1 T. I thought shot put was 2 T's. If shot put is 7.264 kg, it would bring a negative number using line of best fit. That's why I teach maths, because my writing is awful. So we can see that if we convert it from pounds to kilograms and using that line of best fit, it would show us we're having a negative impact. It'd be throwing it backwards, or at least zero. There'd be no, because that line of best fit's a bit ropey. We could have made it a bit more accurate, and it'd been going down here somewhere. So let's move to the next question. Hot tub. Kerry buys a hot tub. She needs a mat in her garden for the hot tub. The mat is rectangular with dimensions 3 meters by 3.5 meters. Kerry has a coordinate grid to represent her garden. Each square on the major grid lines represents 1 meter by 1 meter. So we're going to go like this. I'm going to do it over in the corner so it doesn't make any difference. So 1 meter. Oh gosh, it's giving me a straight line now. Oh no, that's not a straight line there. So we can see that's 1 meter by 1 meter. The major lines on our grid are 1 meter by 1 meter. Okay. Point A and point B represent two corners of the mat. Plot a possible pair of coordinates to represent each of the other two corners. Write on the graph the coordinates. Right, so if we can see it's 3 by 3.5. So by this judgment here, we can see that's 1, 2, 3. So we've got we're going to draw it in rough over here. So we've got the 3. We now need a 3.5, so slightly longer. And it's not going to be up there, obviously, but we can see that's the 3. So if we go 1, 2, 3.5, we can either go here. That's 3.5. Or we could go 3.5 backwards, couldn't we? We can actually go 1, 2, 3.5 backwards. So there's two possible coordinates here, but we're going to go these ones. I did those first, and we represent coordinates by saying along the corridor. And hopefully you're all shouting at me saying up the stairs. If you heard that for the first time, up the stairs. So that basically means we're looking at the x-axis first, and then the y-axis. So we're going along the corridor, and we're going up the stairs. Obviously, it could be down the stairs as well, because sometimes the axis is minus numbers. But quite often, the graphs here don't have x and y on the axis, and that's just tools for your graph. So what you would do, this is an online exam, we'd pick that x up and we'd drop it here, pick that x up, drop it in here, and we'd label it. So we're going to label them, and we're going to label them C and D. Right, so write on a graph what coordinate, write on the graph what the coordinates are. So we've got C, we'll say C here is along the corridor, so we've got is 8.5, and it's 4 up, so that is 8.5 and 4 for that one. And this one, we'll call it D. That is 8.5, because it's along the corridor again, and it's at 1. So we've put our coordinates in there, we've labeled them, and so how we'd label that, we'd literally use this here to label it, give you a text box, and we just do exactly what I've done there, but with a text box. Next question, 1 mark. Luigi records the number of sales each day for the last 15 days. The scatter diagram shows the number of sales and the temperature on each day. Describe the relationship between the number of sales and the temperature. So we could say, and I don't know if I spell that right, we could say correlation. We could just, with one word right here, it's an uphill. But we're making a positive. We're going up. We're on the up. Positive. We could say it's a positive correlation for our answer. Or again, if you forgot the word correlation, you could say, if you look here, the hotter it gets, the more ice cream he sells. So the hotter the hotter the temp, the more ice cream. I'm not even going to put Luigi. He sells. I was going to put Luigi, but again, the spellings. So we've described the relationship. We've said the hotter it gets, the more ice cream it sells, or we can say it's a positive correlation. Either or is absolutely fine. The mathematical term will be used the correlation, but it's asking for the relationship. So talking about the hotter and the more ice creams wouldn't be a problem. Okay, and that's one marker. Another one marker here. Luigi records a number of sales for each of the last 15 days. The scatter diagram shows a number of sales and the temperature on each day. At a temperature of 23 is forecast for tomorrow. Luigi wants to predict the number of sales for tomorrow. Show on the scatter diagram how to predict the number of sales. So it's giving you the line tool this time here, look. So we'd click on that on the exam and we draw in our line of best fit. And that's not brilliant, but it's not, yeah, it's not. I'd make it a little bit more. I'd incorporate more of those. There we go, that's better. So we've got some below, some above, but we try and keep in that line as close to as many of the crosses as possible. We don't have to go through any of the crosses. You don't have to go through zero. It's just keeping that line as close as you can, a straight line, to as many of the crosses as you can. This line tool would automatically give you a straight line. So don't worry about my poor handwriting. So it says here, a temperature of 23 tomorrow. So we've got 20 there, 22.5. Oh, wow. So 23 is, have we got 2 squares per 1 degree? Yeah, we have. So it's just the 1 square after it. So we're going to go up the 1 square after it. We're talking, oh, wow, that is tight. There, going across. Oh my God, I got to there, then I went missing. We're going on this line here. I think it's that line, 74. Gone across there and down to there. I've started there, I've gone up to there, and I've gone across there. 74 ice creams. So he's gonna, well, if you only sell 74 ice creams in a day, it's hardly worth it, is it? Surely it's going to be 74 per hour. 74. So we're predicting 74 ice creams. State of predicted number. Okay, so it's a 2-mark question. I didn't realize that. So we've got 1 mark for drawing our line of best fit by how we predict using the current results, and then we've got another mark for actually saying it's 74. So as long as you've used your line of best fit, if it's slightly lower and you've said 73 or 72, or it's slightly higher and you've said 75, it doesn't matter. As long as you've gone from your line of best fit, it's not like up here or something like that. If it's up there, obviously you're not going to get the point. So if it's somewhere in the mix and you're looking like, why is that not? Let me go over there now. Right, I need to move that down. Okay, that's not annoying, is it? Let's move that over there out of the way. Get my pen back. Okay, pen is back. We can move it back. I don't know why it does that. Of all the places, it should disappear while you're actually working, shouldn't it? Okay. Next question. Matt joined a cycle. Oh, it has disappeared now. Matt joined a cycling club. The 1 centimeter coordinate grid shows the position of Matt's house. There we go. Is 1 to 50,000. The cycling club is 2.5 kilometers south of Matt's house. Plot the position of on the notepad. Okay, so let's just scroll down here a little bit. So we know that 1 centimeter is on the map is the same as 50,000 centimeters, and we're going to put here real life. Okay, and we know that the cycling club is 2.5 kilometers away from Matt's house. So and it's a calculator paper. So we know in 1 meter, that's the same as saying there's 100 centimeters. So if we divide this number by 100, 50,000 divided by 100 will give us that number in meters. So divide a number by 100, we'll just take 2 zeros off the end. Okay, so it's 500. So that is now 500 meters. And then we also know that 1,000 meters equals 1 kilometer. So 1,000 meters is 1 kilometer, and we've got 500. So we know now that that is 0.5 kilometers. So 1 centimeter is the same as saying 50,000 centimeters, 50 meters, or 0.5 kilometers. We've been really, I mean, that looks a bit like an M, but it's a C and an M, that's an M, that's a K and an M. So we can clearly see that we've kept our 1 centimeter on the grid at all times is 1. But we've shown the equivalent. When it says centimeters at the top here, we've said 50,000, correct. Then we've changed it to 500 meters. We divided it by 100. Then we divided it by 1,000. We got 0.5. So we could have just done like 500 divided by 1,000 because there are 1,000 in there, and that equals the kilometers. So we did that here. So we know it's 2.5. Look, so he's saying that it's 2.5 kilometers away from his house. If we look at these two numbers here, we've times that by 5 because it's 5 times bigger. It's 5 times bigger. 0.5 add 0.5 add 0.5 add 0.5 is 5 times bigger, so it's 2.5 kilometers. So we need to make this number 5 times bigger also. So 1 times 5 is 5. So we can clearly see that 2.5 kilometers on our map in real life is represented by 5 centimeters on the map. So each one of these, and it says south that we can see here. So we got north, east, south, west. You probably all have rhymes. Naughty elephants squirt water. Never eat shredded wheat. Lots of different ones. So north, east, south, west. We're going south. We're going 1, 2, 3, 4, 5 centimeters down, and we're going to click on there. Well, we click on there and put an X there. It doesn't give you an option to write cycling club on there, but if it did, you could just write cycling club like that. For 2 marks, a bit more involved that one. We had some conversion to do, but only shrinking conversion, not converting it into miles or anything like that. We had shrinking conversion. So as long as you remember the 100 centimeters in 1 meter and then the 1,000 meters in 1 kilometer, you're going to get that shrinkage correct. Okay, let's go. Lily wants to book some lessons with Marco. She wants to know how many hours of lessons she might need. Marco gives Lily this scatter diagram showing the exam result and the number of hours 19 of his former students took. Draw the line of best fit for 1 mark. 1 mark. Drawing. Line tool again, look, you'd click on the line tool and first attempt or whatever. Once you've got your line in on these ones, like that's too high, you can just drag your line down a bit, whereas I can't. I've got to rub it out and start again. Oh, I done it again on it there. Why did it do that? It's because I clicked on there. No, let me move it out of the way again. Click on there. Okay, my pen's back. So let's go for second line of best. Why Salon Rubber? That is annoying. I want to put it right in the middle of my page, so it's not definitely not going to be getting in the way now. Right, so second attempt, line of best fit. Let's go. Yeah, much better. Okay, so we've got a better line of best fit. I remember the next question on the exam. Hold on. Lily wants to book some lessons. She wants to know how many lessons Marco gives this scatter diagram showing the exam result and number of hours lesson for 90%. Oh yeah, so that's just the first question. The next question on the same exam, I've actually copied and pasted that one as well. No, the next question is saying she wants to pass in. She wants to have 80% pass. I remember the question. We did it on the percentage questions a couple of days ago. So there is the follow-up question to that. That's the good thing about the NCFE. For 5 or 6 questions, you're working with a theme. And I'm not saying that they're all believable, because there's that one about the planets and things, and that's not my cup of tea. But they generally are life-like scenarios. So driving lessons is quite an easy one. We've all had driving lessons before. And 1 mark, a lot of the representing and interpreting data are 1 or 2 mark questions. There's very rarely a big question right at the start. You might get ones leading on from it. Like I said, we had to look at the percentages of something last time. Marco wants a shed in his garden for the science equipment. He uses this coordinate grid to plan the space for the shed in his garden. Amazing. The floor of the shed will be square. The points A and B are 2 corners of the shed. A and B, we can see them here. Quite comfortable. Well, this has got X and Y, so we don't need to worry about along the corridor. But I will write it along the corridor up the stairs. Okay, so we know it's going to be the X number followed by the Y number. Okay, so points the line AB shows one side of the bed. Write down the possible coordinates for the other two. We said it's square, so we're going from 1, 2, 3, 4. We've gone 4 squares down, so it's 4 squares. So we're going to need to go 1, 2, 3, 4. So I'm putting 1 there, and I'm going to go 4 across there. Likewise, we could go the other side. I don't know why I always go right. Maybe because I'm right-handed. I'm always kind of looking at going to the right. So we could have gone 1, 2, 3, 4. We'd have gone to there, and then it'd been likewise there. So we go along the corridor first. We can see these both are 3 for our along the corridor. And then we look at this one first. We'll say, oh, we'll go with this one first. We'll say that's C. And only because you can relate mine. They won't have labels on. You won't need to write labels on yours, just so we can identify them. And we can see the C is -3. My bubble has appeared on the screen and saw it appear and disappear. It's disappeared again. And then the top number is 1. So that's there, 1. So we've done 2 marks there for 2 coordinates. Oh, that's a bit weird how my bubble keeps disappearing. I didn't notice that. Right. The cargo ship is sailing from Hong Kong to Dubai. The distance between these 2 ports is 6,631 miles. Elsa uses this scatter diagram to work out the speed of her cargo ship on this route. The cargo ship has a mass of 190,000 tons. Sets sail at the speed of the ship which has the same mass. Calculate the time at which the cargo takes to travel 6,631 miles, giving us the nearest hour. 3 marks, biggest question we've done so far. Let's have a look. Let's have a look. So we've got 190,000 tons. So we've got 150, 175. So we got each space is worth 5,000. So we have to go 2 spaces on. So we can see. Wow, can I make that bigger even still? Yeah, I can. So if I'm going up at 190, I am looking at that. This one here, look, there's one, it's saying, oh gosh, now my pen has gone. It sails at the same speed as which the ship has the same mass, and there's only one ship. Why is it doing that? There's only one ship that has the same mass. These are all on 200. That is the one that's here on 190. So we're sailing at that speed. Oh my gosh, now we have to go right across. I could do it like a ruler on my screen here. Right across, right across. Am I looking there? Is it 2 below? 1, 2, yes. 2 lines below the thick line. So 2 lines below the thick line, so we can see that's 24. 21, 22, 23, 24. So it's going 24 miles per hour. So we've gone up at 190, and then we've gone across. And again, excuse my bit blurry lines, but we've gone up. So the best way, it's not asked for a line of best fit. It's stated that it's going at the same speed as the other ship at the same weight. So it's going 24 miles per hour. It's got to go. Wow, it's got to go 6,631 miles. So if you remember this, that's not. We've got the distance. What says distance, speed, time. So we have got 2 of those digits, and we've got the distance. And if we look at the distance, either or, so if we want to find out time, we've got distance divided by speed. If we want to find speed, we've got distance divided by time. So that line across is acting like our divide symbol. And then when we want to find distance at the top, these 2 are multiplied, so they're next to each other, so we just times them. But we have the distance, which is 6, 6, 3, 1. We've got the speed, so we're going to divide it by 24. And that's going to give us, wow, how many hours? Let's go with my calculator again. So we've got 6,631 divided by 24 miles per hour. 276. Wow, okay, 276,291, 276,291. Right. So it's the same speed. Calculate a timing carry shoot takes. Give you answer to the nearest hour. So that's saying 276 hours. If you look at that 0.2, okay, it's not 0.5, is it? So because it's 0.2, we're saying 276 hours to the nearest hour. If we had to round it up, so if you said round up to the nearest hour, we automatically have to round up. There's a piece, it's like those questions that say about whole slices of fence or whole tins of paint. We can't have, 0.2 of a tin of paint, so we'd go for 277, but it's asking you to the nearest hour. And the nearest hour is 276 because that's not over halfway. So 276 is the right answer. Let's scroll down. I think that's a bit smaller than the rest, but it's the last question, so I won't make it any bigger. Abdul uses coordinate grid to plan the front lawn. The front lawn will be a parallelogram. When I think of a parallelogram, I think of two train tracks crossing each other, and again, this don't kind of like it doesn't matter which way they go. So two train tracks are crossing each other. What you find with train tracks is they'll never meet because they have to be the same width apart because the trains sit on them. So train tracks are like a parallelogram. It doesn't have to be like that. It could be literally like that. It doesn't matter because there's two sets of lines, and those two sets of lines cross, and they keep going and going and going on. So the parallelogram is this part here, and it's this part here. Oh my gosh. Okay, so it's the in bit. So the parallelogram is the bit between the two sets of parallel. Oh, it's gone. Can I do that with that one as well? No. Why would it do it twice? No, obviously it wouldn't do it twice. So let's go like, no, that's not parallel. Let's just keep the one that I did that's parallel. Okay, so we've got that part in the middle that we need to look at. Point A and B are two corners of the parallelogram. Point A and B. Point C is at 4. I remember when we go along the corridor. Up the stairs. So we're going to x-axis and we're going to y-axis. So the x is first, the 4. So the first number, point C, is at 4 minus 3. Okay, so now if you think about this as a parallelogram, we know that this point and this point has to be the same distance as this point and this point because the lines are going to be parallel, so they never meet. Okay, so we've now got, let me rub all those out because they weren't the right place. So we can see that 1, 2, 3, 4, 5, 6, 7 below. So 1, 2, 3, 4, 5, 6, 7 below. So that's your answer. Mark the points on the grid. Don't have to label them. Just mark them on there. We're using the X. You pick the X up, drop them in. So once you've got that, it's telling you what that first one is. Telling you what that one is. And so once you've got that first one, you can clearly count how many spaces you're going down, and you do the same with that one because the two lines can never meet. They always have to be the same. Likewise, if we did the upright ones, those never meet because they're going straight up. And that is the last 4 lots of exam questions, or the last 4 exams, all the questions that involve interpreting graphs. So as you can see, 1761, 1761, there's 2 questions about graphs on that one. 2126, 2126, there's 2 questions on that one. 2132, 2132, 2132, so there's 3 questions on that one. Oh, 4 questions, there's one there as well. And then 2138, 2138. So on average there, we're looking at a minimum of 2 questions on an exam that involve interpreting data, with that exception one in the middle where there's 4. But you can, if you get the gist of expecting 2, and you can see, like, sometimes you've got to draw a line of best fit, sometimes you've got to tell them what it is, sometimes you're plotting a point, building a garden, again, drawing a line of best fit, identifying it, looking at a relationship of, using the graph to interpret the data of how many ice creams, plotting again, using scale. So there's a mix of questions, but generally, apart from that last one, they are 1 and 2 pointers. And these are 1 and 2 pointers that we should be easy collecting because all the information that we need is right in front of us. It's on there. We're not having to do any math with it. We're just interpreting. We're looking at what's on the sheet in front of us. Perfect. I will stop sharing and stop recording. And yeah, I'll send it out to everybody now. Thank you very much.